Good morning, everyone. I'm Dhruti from Venkateshwara College of Engineering, Bengaluru. I'm going to give you a small presentation on collection classes in Java. Let's move to the introduction. What do you mean by collection class? Collection class. In Java, collection classes are a group of classes that are used to store and manipulate group of related objects. These classes are part of the Java collection framework. Java collection framework, which means we are going to put all the objects in a single entity, or we can consider as we are going to put all the objects in a single box together and give it a common name. So that thing we can call it as Java collection framework, which is a set of interfaces and classes that provide a unified, high-performance way to store and process collection of objects. Collection class is one of the utility classes in Java collection framework. The java.util.package contains the Java collection class. Collection class is basically used with the static methods that operate on the collections or return the collection. All the methods of this class throw the null pointer exception if the collection or object passed to the methods is null. We can declare the syntax as public class collections extends object. And Java collection framework consists of various classes that are used to store objects. These classes on the top implements the collection interface. Some of the classes provide full implementations that can be used as it is. Others are abstract classes which provide skeletal implementations that can be used as a starting point for creating concrete collections. Java collection framework classes. We have abstract collection, which implements most of the collection interface, abstract list, which extends abstract collection and implements most of the list interface, abstract queue extends abstract collection and implements parts of the queue interface, abstract sequential list, which extends abstract list for use by a collection that uses sequential rather than the random access of its elements. Linked list implements a linked list by extending abstract sequential list. Array list implements a dynamic array by extending abstract list. Array DQ implements a dynamic double-ended queue by extending abstract collection and implementing the queue interface. Abstract set extends abstraction collection and implements most of the set interface. We have enum set, hash set, linked hash set, and priority queue, and many more. Various collection classes in Java. We have list, set, map, queue, and dequeue. List, an ordered collection that allows duplicate elements. Example includes array list and linked list. A set, an unordered collection that does not allow duplicate elements. Examples includes hash set and tree set. Map, a collection that maps keys to values. Example include hash map and tree map. Queue, a collection used to store elements prior to processing. Examples include priority queue and linked list. Dequeue, a double-ended queue that allows elements to be inserted and removed from both the ends. Example includes array dequeue and linked list. Let us see some of these collection classes in Java. Let's see ArrayList. In Java, ArrayList is a collection class that provides a resizable array implementation of the list interface. It allows dynamic resizing of the underlying array to accommodate the addition or the removal of elements. Let us take an example here. Import java.util.arraylist. First, we have to import the ArrayList class from the java.util.package, and then you're going to create a class name called as ArrayList as an example. Then we are going to move to the main function, that is public static void main. Then we are going to create an array list class of type string, which is mentioned in the angular brackets, and we are going to create an object for that array list class. The name of the object is the list by using the new keyword. Then we can perform any of the functions of the collections to the array list class. We are going to perform the add function here, that is list.add 1. We are going to put the 1 in string into the array, which having the index that is 0. Then we're going to add 2 string to the list, which is having the index at 2. Similarly for 3, 4 and 5. And we can perform removing an element from that array list also, that is list dot remove the 2. 2 will be removed, which is in the index position 1 from the array list. We can also know the size of the array list, that is list dot size. We are going to print it by using system dot out dot println, and the size of the list is given as list dot size, which is going to print the total size or total elements which is present in the array list. And we can also iterate over the list, which means you're going to uh, display it on the screen. Elements of the array list will be displayed by using the for loop. We are going to take an element which is a variable of type string, and you're going to iterate through the list till the end of the list, which is given by colon and list. Then you're going to print system.out.println element. Every element will be printed. We can also consider some of the characteristics of the array list, that is, it does not accept the duplicate objects. It maintains insertion order. Insertion order is predictable, dynamically growable, and it is also shrinkable. It is going to accept both homogeneous and heterogeneous. Let's look into another collection class, linked list. Linked list is a concrete subclass of the list interface. It belongs to java.util.package. It maintains the insertion order. Iteration order is predictable, dynamically growable, and it is shrinkable. It will also accept the duplicate objects. It can store both homogeneous and heterogeneous objects. And we can see the steps to create a linked list is that you're going to import the linked list from the java.util.package. You're going to create the object using the constructors. We can see the example which is mentioned here. That is, first import java.util. Then we are going to create a class named CFG. Then we are going to move to the main function, that is public static void main. Then you're going to create a linked list class of type string, which is having the object name as L. And we're going to similarly we can perform the collections operations here. So that is L dot add. You're going to add A, B, C as mentioned in the array list also. And that last add function, it is going to tell we are going to add the element E to the index position 2. Then we are going to print all the elements. Similarly, in the array list, we can also remove the elements in linked list also by using the remove function. And finally, after removing, what are the elements which are present in the linked list can be displayed. So we can use remove the first element or the last element by using the function remove first and remove last. Let's move to the another Java collection class. It is hash set. Hash set in Java, it is a collection class that provides an implementation of the set interface using a hash table. It is used to store a collection of unique elements and provides constant time performance for the basic operations regardless of the size of the set. So we can see here first we're going to import java.util.hashset. Then we're going to take it an example, that is hashset example as a class name. Then main function. Similarly, we are going to create a hash set class by of type string and the name of the object is set. Similarly, you're going to perform the add functions, that is we're going to add 1, 2, 3 and 4, and we can also perform the remove function, that is we're going to remove the element from the hash set, and we can know the size of the hash set, and we can get the size of the hash set, and we can iterate through the hash set using the for loop. Let's move to another Java collection class, that is treeset. In Java, treeset is an implementing class of set interface and belongs to java.util.package. It will not accept duplicate objects. It will not contain insertion order. It by default stores the last element in ascending order. We can predict the iteration order. It can accept only homogeneous elements. We can look into the example here, that is import java.util.treeset and public class A. We're going to declare a class which is name as A and the main function. As mentioned in all the other classes, we are going to create a class that is treeset, and we're going to create an object, and we are going to add the elements that is of type integer to the hash set. We are going to print, and we can perform remove operations, and we can get the size of the hash set also. Then comes the ArrayDQ. ArrayDQ class implements the DQ interface. It facilitates us to use the DQ. So unlike Q, we can add or delete the elements from both the ends. ArrayDQ is faster than ArrayList and stack and has no capacity restrictions. We can see an example. We have created a class named as A, and we are going to move to the main function where you're going to create a DQ class of type string, and you're going to create an object that is DQ using the new keyword, and you're going to use the add functions, and you're going to add the string values to the DQ, and you're going to print the values elements in the DQ by using the for loop. Then comes the priority queue. Queue interface maintains the first in, first out order. It can be defined as an ordered list that is used to hold the elements which are about to be processed. So there are various classes like priority queue, DQ and array DQ which implements the queue interface. The priority queue class implements the queue interface. It holds the elements or objects which are to be processed by their priorities. Priority queue does not allow null values to be stored in the queue. We can see the example as mentioned or as explained in all other Java classes. Here we are going to import the that is java.util.package priority queue. Then you're going to create a class named as priority queue example, and we are going to move to the main function, and here you're going to create a priority queue class of type integer, where all the other classes were created of type string, but we're going to create this by type integer by using the queue as a object, by using the new keyword. As mentioned, we can use all the collection operations, that is add, remove, get the size, everything. So we can add the element that is 5, 1, 3 and 2, and you can also remove all the elements, and q contains 3. It is going to return the boolean value. Q dot size is also going to return 0 because you have removed the q value, and you're going to check if it is empty. Then q dot poll, it is a function. It is going to check whether the elements are present in the queue or not. These are the some of the Java collection classes which can be seen here. Thank you.